Hello, I am Matai from the RoboRoos East FLL team. Today we will be continuing on from last time with our XY coordinates. Before we start making our graph generator in Mindstorms, we need to go through the maths of it. So as discussed last time, in a right-angled triangle, we found that the sides have a direct relationship to each other, being Pythagoras' theorem. But this is also true of the angles. The ratios between the sides and the angles can be expressed using three terms: sine, cosine, and tangent. What this means is if we take one of the two angles in this triangle that isn't the right angle, we can call it the Greek letter theta, which is the term usually described for an unknown angle. So in this scenario, there are three sides of the triangle. Two that we consider relative to theta, and one that is a constant, and this is the one that's opposite of the right angle, and it's called the hypotenuse. The other two sides are called the opposite and adjacent, and the reason they're relative to the angle is because the opposite is the side that's not touching theta, and the adjacent is the side touching theta, which means that if theta was over here, then now this side would be the adjacent and this side would be the opposite. So the sine of theta is the length of the opposite over the length of the hypotenuse. The cosine of theta is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And so these three terms are called the trigonometric ratios. So if these are a direct ratio between the sides and the angle, then from knowing one angle that we'd get from the gyro in this case, and how far we've gone, which would be the hypotenuse as described last time, then we can calculate how far up or across we moved. In this case, our angle, or what we're measuring from, or theta, is down here, meaning that the x, or across, is adjacent, and the y is the opposite. Now, this is different depending on how you start the robot, but we'll get into that later. So if the sine of theta is equal to the opposite over the hypotenuse, then what we can do is we can multiply both sides by the hypotenuse, which would give us the formula sine of theta multiplied by the hypotenuse gives us the opposite, thanks to the laws of algebra. So what that means is the sine of this angle multiplied by the hypotenuse will give us the length of the opposite, which is this. This is also true of cosine, which is adjacent over hypotenuse, and so you just multiply both sides by hypotenuse again, which gives you theta multiplied by the hypotenuse, or cosine of theta multiplied by the hypotenuse gives you the adjacent. So what the tracker does is it just does this, but it divides one of these lines into lots of tiny little lines that make it up, and it calculates the change that has been done. So we know how far we've gone since the last section or measurement, as well as the angle we're going at, so we can find where we are according to x and y. This even works on curves due to how small these measurements are. So now we can start creating this in Mindstorms. First, you need to create a variable called lost distance. And if you remember from last time, you just go up to this little tab, and you click add variable, lost distance. So then what you have to do is you can just delete that, and then you can add in a loop, which can go for infinity, and add in a motor read block, and from here add a lost distance read maths block. And then you have to put in a subtract maths block. So now you add in a lost distance read block. And you create a subtract maths block. And just plug motor read into port A and lost distance into port B. And then create another lost distance, but this time make it right, and put in the result of the subtract block. So what this does is it just measures how far the robot has gone since its last movement, and then sets whatever it is to however far we've gone, so that we know the next time we move how much we have to change by. So from here, I suggest making a new line, and the way you do that is you can split this, and for now we'll just put in another variable block, say down here. Don't forget to expand your loop to fit it in. And what you can do is, instead of having this wire go up here, you can bring it down to here. And you've got yourself a second line. And so now just make a gyro sensor read block, and you can delete the placeholder you used. And then you have to create 2 advanced maths blocks. So just advanced. So in the first, you want to type in the formula cos A times B, and in the second you want to do sine A times B. And if you don't want to write it, you can also find all of the trigonometric ratios down here. And so now you just plug in the gyro read into port A of both of the blocks. And then take the... oh, hold on, sorry, that was issue. So here, instead of putting subtract into last distance, you have to put the motor read into last distance. And then you put the subtract maths block into port B of both of these blocks. Sorry about that. So now what this will do is it will calculate the changes in X and Y since the last measurement. Okay, so now I just need to make it look a little better. Okay. And so here again, I would suggest making a new line. And add in that X last variable we created last time. And just set that to read. And now just add in a maths block, just an add block, and then put in another X last block and set it to write. Now take the Y from the last X and put it into the plus. Then take the result of this cosine block, maths block, and bring it into this plus section. Oh, oops. And plug in the result of that into X last, and that'll give you the X coordinate. And so this will be your total X coordinate, not just the change. So you'll get it to accumulate. And so that's now all of the maths you've done for the X. And all you have to do for the Y now, if we make a new line, so if we make a new line, what you do is you can just copy this and put it below, and take the Y from up here and connect it up. And all you have to do now is change it from X lost to Y lost, and plug in the result of the sine block into this addition. And there you go, you've got your tracker. So now that you've done that, you can just select this loop and go Tools, My Block Builder, and call it Tracker. And you can give it any icon you want, and yeah, you don't need any inputs or outputs, so you just click Finish. And so now you've got that, you can test it. So similar to what we did inside of the tracker, you can make new lines here to make things run at the same time, just in case you didn't know that. So what we're going to do is we're going to put the tracker here, and then we're going to add in a little loop here and plug this in. And so what we're going to do here is we're just going to display our X and Y coordinate. So you just add in 2 displays. Make sure to set them to text grid. And on the second display, you have to remove the erase function. And also on the second one, make sure to change the Y to 2. And here we'll just make these 2 wired. And what you can do is you can read from both variables. And plug them into add. And so the first one will be X lost, the second one will be Y lost. And so the best way to test this is you can make another line and put in that move distance we made. And then from there, create yet another line and plug it in. And what you can do is, for example, if you set it to angle 0, you can give it a distance of, say, 20, the speed of 20. And you can ignore this last one. This one's going to be different from yours. We'll be going into that a bit later. And then you can just send it off. And so you just don't forget, at the very beginning, before you even start the tracker, you need to initialize all your variables so that it doesn't give you errors. So just initialize X lost, Y lost, and last distance. And you can just set them all to 0, so you'll be starting from 0, 0 in the program. And so yeah, you can test from that. And so just to note, the tracker begins relative to the starting direction of the robot. So if you begin the tracker when it's facing the top of the board, the X and Y will be in a different directions than if you start it looking towards the other end of the board. So the long side, for example. And so next episode, we'll go through how to make this work in whatever direction you want, but the graph will still stay in the same position. And we'll also be going through the directional portion of the movement. So thank you for watching, and I'll see you in the next video.